Hello again. In this video, we will examine the multiplication rule. For starters, let us examine the conditional probability formula once again. The probability of event A given B equals the probability of the intersection of A and B over the probability of event B occurring. We can multiply both sides of the equation by P of B to get the probability of the intersection of A and B equals the probability of A given B times the probability of B. We call this equation the multiplication rule. Let us look at a numerical example and see why this makes sense. Suppose the probability of event B is 0.5 and the probability of event A given B is 0.8. This suggests that event B occurs 50% of the time and event A also appears in 80% of those 50% when B occurred. Therefore, the likelihood of A and B occurring simultaneously is 0.8 times 0.5, or 0.4. Let us look at another example. Suppose we draw 2 cards from a standard deck of 52 playing cards. We draw one, shuffle the deck without returning the card, and then draw a second one. Assuming we did not draw a spade on the first draw, what is the probability of drawing a spade on the second draw? If we express these as a single conditional probability, event A would be drawing a spade on the second try, and event B would be not drawing a spade on the first try. As stated before, the likelihood of drawing a specific suit is 1/4, or 0.25. We already discussed how to calculate the probability of complements, so the probability of B would equal 1 minus 0.25, or 0.75. Now, be careful when estimating the probability of drawing a spade on the second turn. There are only 51 cards left, so we must adjust the favorable overall formula to find the new likelihood. We have assumed we did not draw a spade on the first go, so the favorable outcomes would still be the 13 spades left. However, we are 1 card short from having a complete deck, so the new sample space would be 51. Therefore, the probability would be 13 over 51, or approximately 0.255. Great! So far, we have calculated the likelihood of not drawing a spade on the first turn and the probability of drawing a spade on the second go, given we drew something else first. However, we still haven't answered the question we are interested in. What is the probability of drawing a spade on the second draw, assuming we did not draw a spade on the first draw? To answer it, we need to apply the multiplication rule. We plug in 0.255 for P of A given B and 0.75 for P of B in the multiplication law formula to get a probability of close to 0.191 for the intersection of A and B. So we have a probability of 0.191 of drawing a spade on the second turn, assuming we did not draw one initially. Marvelous work, everyone! For homework, you can practice your understanding by finding the probability of getting a spade on either the first turn or the second turn. You could solve it in 2 separate ways, by using the additive law or by using the multiplicative rule. Thanks for watching.